All right, continuing on, we are looking at the right angle relationships. This is a proof that you must know. And I'm going to remove these for a second. They shouldn't be there. I'm going to put them back in. Here we have CD is perpendicular to AB. And by Euclid's definition, that means that the angles on either side of the perpendicular are congruent and right angles. We want to show that AB is perpendicular to DC as well. Euclid's definition doesn't allow for that. So in order to do this, we construct these two circles. One large one around A, which passes through D and E, and one smaller one which sets these 4 points equally distant from the center. Alright, if I connect AD and AE, we can make a statement about these. They are radii of circle A, and that means that AD is equal to AE because they are radii of circle A. They are also chords in circle C, and congruent chords in a circle intercept congruent angles. Since ACD intercepts AD and AE is intercepted by ACE, that means angle ACE and angle ACD are congruent angles. So angle ACD is equal to angle ACE because AD and AE are congruent chords of circle C. And anytime adjacent angles are equal and form a straight line, we have a perpendicular. So AC is perpendicular to, and I guess we shouldn't call it AC, we should call it AB to fit what it is we're trying to show, to CD because adjacent angles are congruent and form a straight line. And this is the end of the first proof. So these three lines, you need to be able to reproduce them on the test. There's no hints other than to have this drawing, but it will not have the two lines in it. So you have to make sure that you remember that those two lines are there. The 2-3 angle measurement proofs are all about showing that our definitions up here relate directly to the degree measurements that we know they should. So this first problem is all about showing that a straight angle is equal to 180 degrees. We start with the angle addition postulate. Incidentally, take a moment to see if you can do these. All right, here we go. Angle ACB is equal to angle ACD plus angle DCB. We need to say something special about these two angles based on the fact that they're perpendicular. What is that? We know that angle ACD and angle DCB are right angles because of the perpendicular lines. And this also means that angle ACD is equal to 90 and that angle DCB is equal to 90. So, we're going to take this and we're going to make a substitution. Go ahead and do that. Angle ACB is equal to 90 plus 90. Now we're going to combine like terms. Angle ACB is equal to 180. Since angle ACB is a straight angle, and it measures 180 degrees, all straight angles measure 180 degrees. Alright, our acute angle works the same way. Again, write the angle addition postulate for this drawing. Angle DAB is equal to angle DAC plus angle CAB. We want an inequality. You want to pick out the angles that are important. Of course, DAB is part of it because it's the one by itself, but then we also want to use CAB because it's the angle that we're focused on. So angle DAB is greater than angle CAB. Now we need to identify the result of this perpendicular. We're looking at angle DAB, and we need to identify what kind of angle it is. Angle DAB is a right angle. So angle DAB is equal to 90 degrees. Then by substitution, 90 is greater than angle CAB. Angle CAB is less than a right angle, so it is acute, and its measure is less than 90 degrees. So all acute angles are less than 90 degrees. And now we do the obtuse angle the same way. Go ahead and do the angle addition, but this time we are ignoring point E, just CAB and the right angle. Angle CAB is equal to angle CAD plus angle DAB. By inequality, angle CAB is greater than angle DAB. We're not interested in CAD because we want the right angle. The perpendicular line lets us say that angle DAB is a right angle, and that the measure of angle DAB is equal to 90 degrees. By substitution then, angle CAB is greater than 90. Since angle CAB is more than a right angle, it is obtuse, and its measure is more than 90 degrees. So all obtuse angles measure more than 90 degrees. Okay, now let's do the proof for greater than a straight angle. Again, segment addition postulate. By inequality, angle EAB is greater than angle, this should be CAB, not CAD. Then angle CAB. And we know that angle EAB is equal to 180 degrees because of that whole straight angle bit. So by substitution, 180 is greater than angle CAB. All right. So angle CAB is obtuse. We already knew this from our previous proof. And less than 180 degrees. So all obtuse angles are less than 180 degrees. Alright, and that's the end of all the proofy type stuff. The rest of the things that we have to worry about are all calculation based. Maybe a little proofy from time to time, but mostly calculation based.